Good afternoon, everybody.
Yeah, good afternoon. I'm here.
Yeah.
Afternoon, sir.
The foundry industry in India has a favorable outlook in terms of profitability, driven by domestic demand, export opportunities, and relatively lower production costs. However, addressing challenges related to technology updation, skill development, and environmental compliance will be crucial for sustaining and enhancing profitability in the long run. In this backdrop, to handhold our industry for a long-term profitable business, we are organizing the webinar 5 Levers to Pull to Improve Profitability in Foundry Operations. Mr. Girish Hebbani has agreed to be our speaker in a very short span of time, and I thank all our distinguished delegates for this important session, for attending this. With this, I'll request our President, Mr. D.S. Chandrasekhar, to deliver the welcome address, please. Over to you, sir. Sir, you are muted.
Unmute. Yes.
Yes.
Namaskar and greetings. I welcome all the participants for today's very important topic. Mainly to the foundries are profitable, but not to the desired profits. Certain foundries still struggling. It's a very good topic we have chosen, and we have with us special welcome to Mr. Girish Hebbani, founder and CEO, Agna Advisory. A very interesting personality. I just saw this one. He is almost has got 30 plus years of leadership experience in MNCs across 15 countries. It's very, very amazing, and that too with the multinationals. So it's fortunate that we have with him to know about how to improve the growth. The profit will not come only with this one. There has to be a growth at least 15 to 20% CAGR, and profitability, measuring progress and performance, and which are the best practices that will bring in a lot of bottom line. With that, and these are all 5 levers we are told about to pull the to the foundries to the profitable position. We are keen to hear you about these levers, sir, though we are practicing few of them. So I request once again, welcome all the participants, my friends in NOB and the executive director, and for today's very special webinar. So thank you once again. I welcome you all for the future 2 hours we have got this session, right, madam? Webinar.
Yes, sir. So
yeah, thank you.
Thank you, sir. So just to introduce our speaker briefly, as President has already told that he has a vast experience of 30 years of leadership in MNCs across 15 countries. And he has held senior roles as managing director, president director, and general manager in mining equipment, construction, and manufacturing organizations. He holds a bachelor's degree in engineering from India and an MBA from Australia. He is a certified PMP, Lean Six Sigma practitioner, and has 2 technology patents. His expertise in managing large multicultural teams and building high-performing teams and providing holistic growth and profitability outcomes makes him a unique and invaluable advisor to companies. He's an author of 4 books and a sort of a speaker and thought leader. Girish ji contributes regularly to forums and conferences as founder of Agna Advisory that provides business improvement services, and Agna Academy. He inculcates business improvement techniques and thinking within line managers through learning programs based on shared wisdom, best practices, and real-world applications. Passionate about improving manufacturing in India to world-class standards, Mr. Hebbani also champions responsible resource use and sustainability of the planet. Over to you, Mr. Hebbani.
Yeah, thank you very much for the kind introduction and those kind words. It is really a privilege to be in august company of so many of our fellow foundrymen and women, I suppose I should also add. So yeah, I do thank the IAF for giving me the opportunity to speak and share my experience, and I hopefully will be able to contribute my experience as to how I have approached business improvement over the many years that I have served the industry. So I will start with sharing a screen, and hopefully we can start with the presentation. Okay, so what are we going to talk about, as we have said earlier, is, well, how do we improve profitability in foundry operations? So the first thing, of course, is, so if you say, well, what is the problem that we are ultimately solving? So the situation is that I'm sure each one of us, whether you are an owner, a CEO, a plant manager, a line manager, have all been asked this to say is, well, we need to do more with less. And to be a very topical thing is that labor is a huge shortage within India and anywhere around the world. So the first question that comes up is, how can we get, do more production out of less labor? And let's see if I can answer those questions for you, going forward. So the first thing, of course, is, okay, how do we improve growth, profitability, and cash flow? This is a very common there is a very common question that is asked in many boardrooms and everywhere else as to and it's a common conversation. So hopefully I'm hoping that this presentation provides some insights on how to increase revenue, reduce costs, and reduce things, because those are the only three main areas that you can work on to improve your profitability and cash flow. So what is the solution? The solution is a proven business methodology. So it is a combination of a lot of things that I've worked on over a number of years to then be able to be able to put it into a format. So so what is the guaranteed success? At least am I willing to put my reputation on it that says, okay, this is the core promise of the business methodology. It should deliver you an increase of profitability by 10%. You could be able to grow by 20 and reduce your working capital requirement by 30%. So hopefully, the first question that comes up is, well, why are we here, and what will I learn? Because that will be that's part of the learning process which I'm trying to impart. So we do have a common purpose, and like mentioned before, that okay, this is the future, right? India is at the cusp of growing, quite rapidly into to many trillions of dollars worth of economy over the next 10 years, and therefore the Indian manufacturing needs to become world-class. To be able to compete with the best in the world, we do need to improve our operations and do our, supply our products and services at a world-class level. The most important thing, of course, is that's what we are all here for, is to help customers make money. So, that is my passion as to what I want to contribute towards Indian manufacturing, because I've just come back to India with the hope of settling here long-term after spending 32 years in being overseas. So, so that's the whole idea. Now, what is the shared learning that we are going to achieve today? And some of the insights, okay, you've already seen the brochure that basically talks about, what the various topics are. But in essence, what we're trying to gather today is, answer questions, which is the 5W and 1H question. So hopefully we'll get some answers as we go through. So why listen to me? I suppose people have gone along and spoken about it. The only thing is, okay, I suppose you do have to trust is that, okay, I've got hands-on experience of actually delivering this and being part of the whole operations and being in the forefront or leading this transformation as it is called. So so there is some level of credentials. So I've got a bit of experience, not maybe as much as what the others in this room webinar are. Yes, I've got a bit of education, but most importantly, I've got the experience of working in the boardroom all the way down to the shop floor, and maybe about 20 years of delivering improvement in various organizations. So that being said, I do want to, help use a couple of examples that basically as a story, which is basically rags to riches from Foundries. And before I start my presentation, there is a standard disclaimer about the content as well as fair use policies, so that there is no there's no copyright claimed on on some of these things that have been presented. So then I do acknowledge now. All foundries are different. So it is not that the one solution will fit all, and therefore, the methodology will work, for every single thing, but they will be a combination of various things that will deliver the required results. This again is a trailer only, because trying to fit a lot of things into 1 or 2 hours, there's a lot of condensed info, which is many years of experience being condensed into a very short presentation. So all I want to say is the main movie is going to be screened later if more people are interested. But what I want to highlight here is that the stories and actors may be different, but the methodology of making a movie is exactly the same. So that is what hopefully I can impart to all our listeners here today. So let's get back to the problem. We said, okay, if we need to do that, we need to increase revenue and reduce costs and reduce costs. So the next question then gets down to is, well, Girish, you've gone along and talked about about that logical, about that method. So what is about? So we'll start discussing that now. So the methodology is logical and a structured method. So you're breaking down from the problem that you're solving all the way steps down into, well, what are the next steps? So the next step is, okay, how to increase revenue, reduce costs and cash. So hopefully our holistic approach or this method will allow you the information as to what areas to be targeted. So the key areas that I recommend we target at the initial stages is customers, cost, and cash. So that is quite obvious, but this is quite common here with respect to in each of these areas that that is what you need to work on to be able to deliver the overall profitability results. But what we will talk about is slightly things that are different, because these are already things that you already know. But the main thing, of course, is the rationale as to what I propose is doing it as a holistic approach. Why a holistic approach? The main reason is you need to work on your customer, your cost, and your cash together, because your operations excellence is the one that delivers in results in each of these three areas. Now, the question that you ask is, well, why is that important? Because they're all interdependent priorities. You cannot improve your cash position because by saying, well, I will cut my inventory down, and therefore, without thinking about how will this affect my customer. The same thing, of course, is, if I cut my inventory, what is the effect of that on my cost of operations if I run out of inventory of not having enough? Same thing is again with cost that says, okay, am I reducing my costs in areas that may have an effect on my customer? And so therefore, because there are interdependent priorities, any of your initiatives that you take in one area, they're all interconnected, that needs to be covered off so that you're having all three together. And all three is that it is imperative to survive and thrive in this competitive world, because unless you're looking after all three of them together, it is very difficult to survive and thrive. Or you do not, like the president mentioned, is that, okay, you do not operate at your complete potential. So let's now talk about what are those 5 levers that are, that will impact profitability. And this is my experience. So in the foundry industry, or basically with any manufacturing industry, what we do have is you have the customer, you have throughput, you have yield, you have productivity, and you have costs. So in each of these areas, we do have a lot of things underneath. It may be various depending on the type of foundry or type of manufacturing or the things that are happening. But what you generally find is that each of these are important based on the processes that exist. And if you want to increase the throughput through your processes, what do you need to do? So I've just used the foundry processes to then be able to highlight for this presentation. Same thing again with your yield. You start off with what is the yield at the plant level, and then down to the individual work centers or processes that you ultimately have. The next, of course, is the productivity. So the productivity is, how much of capacity is available. Most important, more than your availability, is as to how you're utilizing your capacity. Same thing with your labor utilization and the rest. So, and again, with the with the cost, it is again the same things as to where there are various things that we need to work on. The base, of course, is health and safety, and systems is the foundation, because unless you've got those aspects of it right, most of the other things will not work very well. And I will show you examples why. So now let's get to so what are the 5 most important things that we will try and touch as part of through examples in this presentation? So from a customer quality perspective, we've got throughput through volume and velocity, melting, yield through methods, labor utilization, energy, and the rest. So so let's get started now. The KPI and metrics is that, okay, each of these processes will have its own set of KPIs as to how we should measure performance. I'm not going to go through each one of those, but as we take the examples, you will begin to highlight as to, well, how those relevant KPIs and metrics that are being measured allows you to measure the progress towards your improvement and delivering growth and profitability. So let's get into the next level of detail, because this is important, because these are the 5 areas that I believe to cover as part of this presentation to what is important. The first thing is, of course, the customer. So that you're starting with your customer quality and complaints, because that is the most important, because loss of customers and future revenue have a direct effect on your profitability. So because any quality that is going through all your checks and balances, through your foundry or through your operations, ending up at the customer is most upset. Especially nowadays, and with certain industries, there are a number of delivery critical just-in-time industries where customers are expecting just-in-time deliveries into their inventory. So unless we are able to deliver those things, it becomes very difficult. So you're not qualified as a supplier unless your delivery is at quite a high level. Next, of course, is throughput. So because this is important, because this is your overall determinant of revenue versus your costs and therefore your profitability. Because ultimately, it does not matter what your unit cost of production is or what your product individual cost is. What needs to be looked at is, okay, how much is your total throughput through the plant as to how many how many tons per month or per quarter or year that you're producing against what is the cost, because that is then develops your profitability, and then you're comparing that against the price that the customer is willing to pay. Because very rarely does it mean that your cost plus model no longer works. So you need to work on, well, what is a competitor price, or what is the value the customer sees, and therefore what our costs are and how we can manipulate that going forward. The most important thing, of course, the reason of picking melting for the founding industry is because that is the golden goose that delivers the value to your customers. Because if there's no melting, and if you're not making any casting, this is the only reason for your existence. There is no revenue to be had. Next, of course, is yield. So there are 2 sets of yield. One is your methods yield that says, okay, well, how much did you pour? How much of that went into casting tons, into dressed mass? And then the third one, of course, is your melting yield, that says, okay, how much did I charge into the furnace, and how much did I actually pour into casting? So both of those are important, and it will become obvious as we go forward. Productivity, of course, is that, yes, there is the availability and the utilization, because, yes, there is a major part, because foundry industry is capital intensive. You're now including the machine availability and utilization as an important part of, of your productivity calculation. The third, and of course, is from a cost perspective. Yes, there are various costs, but energy within the foundry industry, because it is energy intensive, and therefore the focus of a lot of international customers looking at how they want to get to sustainability and get to net zero targets in the future. And so and then the total variable cost is something that all the supporting cost of operation that adds to your profit, your costs, and therefore affects your profitability. So that in it, I suppose, is to why, what are the 5 important areas to work on. And okay, before we get into the examples and show how to do it and what has been done, I do want to share a few tips and techniques, because this is important, for most of the operations going forward. First thing, of course, is the philosophy, the change in thinking to solve problems. Because the reason I say we need to change thinking, and this is supported by what Albert Einstein has gone along and said, is that we cannot solve our problems with the same thinking that we used when we created them. What does that mean? Right, your current issues. Sorry, anybody saying something? Okay. So the current issues are basically because our current thinking is the cause of the problems as to what we are experiencing now. If you want to solve those problems, you need to change your thinking. So that needs to start as a base before we say is if we need to deliver any improvement, our thinking need to change. Because if we keep saying, well, we are already doing this, sir, we are, we already do this, but we do not know what the issues are. So the first thing is we do need to start by changing our thinking. The second most important philosophy to apply is that people improve processes to deliver profits. Now, the most important thing here is people tend to start with the process or think that, or by improving, bringing in purely automation or, improving this, that we will get, the required increase in, in productivity and profitability. So in most of the cases, my recommendation is it needs to start with the people. You may ask, well, why do we need to start with the people? Yeah. Everybody has got scooters or cars, or motorcycles. You may get the best raised car driver to show you, do training and say that, okay, this is how you need to drive your car to improve your performance. Or, but the most important thing is unless you as the person applies that knowledge to the process of your driving, you will never get a better improved performance. So therefore, the importance of starting with, looking at from a people perspective. The other philosophy, again, is that, yes, there are plenty of jargon that goes around. You say, well, lean manufacturing will solve all my problems, right? Total quality management, or TPM, or just in time, or those things. Yes, there are various tools that are existing, within the world that will help to improve operations. But what tends to happen is if you focus purely on a particular tool to implement that into the organization, it just becomes very difficult for it to solve the other problems, because like we talked about earlier, you need a holistic view about what needs to be addressed across the whole of the operations or in a plant. So what I'm trying to highlight is that in each of those levers that we just talked about, and those are the drivers that is required, what needs to be improved, you need to use different tools to be able to solve those particular problems. And therefore, the requirement for a much more holistic approach. So the first thing, of course, there are a few techniques. So the technique is, this is quite common. Everybody knows about the Pareto, but my recommendation is that we need to solve for the majority. So let me ask and say why. Because everybody understands is 20% of my effort gives me 80% of my result. And I totally agree that that is what we should be concentrating on, because 20% of your customers gives you 80% of your revenue. But the change that needs to happen is that we need to concentrate on what happens 80% of the time and try to improve the 80% so that you then get better results over whatever is happening. And that is, and I will show that through an example that says is we need to concentrate as what happens 80% of the time. To just give you as an example, with every machine, we tend to look at it and say, well, we have 20% downtime. My recommendation would be, do not look at the downtime. Yes, it is important, but what is more important is your uptime, how you are utilizing that machine when it is up and running 80% of the time. And that ultimately gives you. So there's a slight shift in the way to approach the Pareto itself. So the next, of course, is synchronous flow. And this is, this is important, especially, from a jobbing foundry, because, yeah, because everything comes through in batches, it becomes much more important to then be able to use this technique called synchronous flow. What is synchronous flow, in my opinion, is as long as your processes are producing enough demand, based on whatever the downstream processes that are required, and it is consistently moving through, through your foundry or your factory floor or your workshop, then, so that is ultimately synchronous flow. But there are a number of things that ultimately cause obstacles to the synchronous flow, and therefore that is what is important, to be able to address. The next thing, of course, is demand and supply balancing. Demand and supply balancing needs to happen at all levels because, yeah, this is how demand and supply ultimately looks in every operation, because demand volume fluctuates over, over the month or, over every quarter. But then your supply capacity that exists with is, which is sort of limited because what you can do with your machines and with your labor. So what you're now trying to work through is how you're trying to balance your demand versus as to what you can ultimately supply. Where the issues come up is when your demand volume increases above capacity. And therefore, it leads to either lost revenue, that you're not getting enough orders through because your lead times are too long, or because you're trying to rush things through to be able to meet the demand, your quality is declining, and therefore your quality is declining means your delivery suffers to customers too. The other end of the spectrum.
Madam.
Yes, please.
Yeah.
Okay, thank you. Yeah, so the other side of the spectrum is when your demand volume is below your capacity. So that leads to lower utilization, your wasted resources, and obviously leads to then higher inventory, higher cost per ton. So what we're then trying to work through is, okay, obviously is trying to balance the two, that says, okay, how can I get an optimum utilization so that I can then carry less inventory and therefore a lower cost per ton? And this is not an easy task. And that's you're constantly beginning to look at how my demand is fluctuating. How do I now, schedule my production? How do I plan and make sure that my demand versus supply is as constant as possible? So you're not putting in, you have to bring in labor, for 7 days worth of work this month, and then you have to lay them off and then bring them back in 2 months later. And I suppose that's the the problems that normal operations ultimately face. The last, of course, from the from an inputs and value drivers perspective, for each of the levers that we have talked about, there are some value drivers. The value drivers are basically, you're looking at what the inputs are. The inputs is from information, whether the material is right and the labor is correct. And then you have the process that then looks at, okay, in the process, is my cycle time most ideal? I've got enough process under control, and is it producing manageable defects or rejects? The third thing, of course, is because there is machine utilization, you will then look at, okay, am I getting machine utilization with the right percentage? My labor is being utilized, and of course is that contributes to the uptime, and then you're then beginning to look at what is the causes of my downtime, and therefore how do I reduce it? So in most of these cases, once you start looking at those value drivers, then that leads on to the initiative that says, okay, well, I'm not getting the right information, therefore I need to optimize my planning activity, right? Or my material, I need to improve my raw material quality, or I need to right size my crew. So that's just an example that says, okay, well, those are the type of things that will begin to highlight when you start looking at, okay, what is happening on the input side and in the process, and on the utilization. So this is just an example. That's a technique that you now need to apply. What drives value within my operations? So the throughput levers, of course, is only applies to those work centers which are capacity constrained. So if you've got overcapacity situation, it may not ultimately make a huge difference, because throughput should help you increase your revenue going forward. But it could also be applied to work centers where, for a given production volume, it can reduce the number of shifts of production that is ultimately required. So you can apply that at a individual work center level based on what the demand versus supply is. The third thing, of course, this is from a from a finance perspective. What I recommend is that you look at a double-edged approach to cost reduction. So what usually happens is, in most of the cases, you do have standards within the thing that you use those for your estimates and and pricing your products to the customers. But generally, what tends to happen is that our actual costs are higher than higher than the what we are quoting. So there, because of various cost leakages. So the most important, if that is our current cost, what most of the companies tend to do is we tend to look at that says, okay, well, how do we reduce the variance between what a current cost is and what what the quoted cost or the customer standard cost should be. My recommendation is to actually start looking at how do we reduce the standards itself. Because if you ask the question, well, how long ago were these standards set? And has the world moved on since then with better processes, better material, better whatever, to then get things to say is, okay, so that you can then look at, if I also reduce the standard, it reduces the, improves my cost situation and therefore my profitability. So the last thing, of course, what I want to highlight is it is important for operations to look at from a holistic transformation, because as we have talked about with customer cost and cash to be looked at together, this is now so that when you are applying improvement, taking up improvement initiative, it is not that you can do everything together, but everything together delivers the required outcome for you at the end of the year. The reason is, mostly what tends to happen is you can pick one particular project, say, for example, which is very quite popular is, oh, I'm going to try and get a better price from my supplier. So you ultimately get a better price from a supplier, but it gets lost in the various other things which you haven't concentrated on. So it doesn't really show up on your, on your profit line or your bottom line. And therefore, the thing is to be able to get a holistic view. What is the various things that are happening across the business, and whether or not that is ultimately delivering us the result that we want to get at the end of the day. Okay, so that is, I suppose, more from a theory perspective and from a thought perspective as to, well, what are the various things that can be done. Now, let's look at things as to what are some examples, and these are, the real situation as to what was ultimately delivered. So the first, of course, is, the story about a foundry in South India. Yeah, I do not want to give a location much more than that, but yeah, you would get to understand. So the foundry existed. Yes, there was a like a lot of people said is that, okay, the foundry operations were running okay, but it was not meeting its high potential that was expected out of it, and there were a few other decisions that were made that necessitated that the foundry operations had to be improved. So and yeah, so I was asked to, I was then in India at that point thinking about staying back in India, but then I was called back and I said back to Australia, say, well, can you please look at this for us and help us improve the operation? So the first step, of course, is with a business health check. So when you are looking at that says, okay, what are the various evaluation criteria that you use to do a health check? You start with your safety, quality, delivery, and cost. Yes, there are other things that sit underneath it, and I will explain as we go through. And of course, there are other things. It is like what is the productivity of labor and equipment? What is the cash situation? How the people are, the environment, and of course, from a social perspective as to how much we are contributing back to the community and through our CSR activities. So it is a comprehensive look at as to, well, what are the overall operations, because everything is interconnected with the other. So for this particular foundry, when we looked at as to, well, what was the dashboard or what is the report health check that ultimately said for the four major things which we looked at, from the safety, quality, delivery, and cost. The benchmark was what is there in the green, but as you can see, the actual in most of these cases where is all in the red. Now, the most two important things from a customer perspective was with quality and with delivery. So the quality or our defects per million was running at 3 sigma, and the delivery is running at less than 45%. The reason why that becomes important, I usually use this as an example, is that if we as a customer have got a wedding day and we're expecting our wedding dress to be delivered by your wedding day, And our tailor says, sir, our delivery thing is we deliver 45% of the time on time, and the rest of it, we do it within the next 2 or 3 days. Wouldn't be unacceptable, to us. So, so that is why it becomes important as to why it is important from a delivery perspective. And you can see from a cost perspective, comparable foundries, was supposed to be 100%, but this foundry was running at 143% off as to what that benchmark cost was. So each of these things where, like you said, the actual was in red, and that it necessitated that we had to do something to change this, the operations within the foundry. So when we first met with, with a number of people, they said is, okay, well, we understand we must improve, but the question was how? So the first thing that came up is, okay, well, we need to improve our efficiency. We need to increase our quality, the speed, reduce our cost, and increase safety. So each of the people within the management team and everybody that I spoke to says, sir, we know all of these things. Tell us something that is different, something that we do not know about. And that is where these whole process of transformation ultimately started, with that particular foundry. We started with the safety, and because it is about people, and that is what where we started. So safety, if you looked at what the lagging indicators were, the lagging indicators were showed as a TRIFR, which is the total recordable frequency of 12.3. So 12.3 is a high number where the expectation was that it was going to be less than 4. So when we look at as to, well, what are the inputs that go into driving toward that number, what we did find is, listen, the lost time injuries were increasing, the medically treated injuries were increasing, and therefore the TRIFR was ultimately increasing. So if you look at what had to start with, okay, we had to start with, we can't do much with the final number as to what it is, but we had to start with from a people perspective that says, okay, well, what is what is going on within the operations. So like we've talked before, that, okay, we do need to change the mindset. Okay, what is important? Now, I suppose everybody has gone along and heard it is always about people. It all finally boils down to people, and we've talked about it before. The reason is it is the people who ultimately set the standards and people who have the mindset, right? The machines don't have a mindset. They work based on whatever that you ask them to do. So the most important thing is changing of the mindset. So if the expectation is that we will now somehow get new results, we do need to create a new mindset. And that is what was the initial focus, because this comes through across various things, for all parts of the operations, because, people are central to how to deliver, improved profitability within the operations. So the first, of course, is from a standards perspective, and then because the leadership set the standard. So the leadership is more importantly not just the management of a foundry. Leadership also includes the leading hands, the team leaders, the supervisors, the department managers, the production managers. Yeah, all the people are important because they're all leaders, because they all set standards. So the question that is the first question that we would ask in each of those is, what are we as leaders willing to accept as standards and within the operations? Because anything that we walk past and do not accept, we are then accepting that says is, okay, well, that is okay for happen within my operations. So the first thing is these are some pictures, and I'm not sure if there are people from the foundry itself at this, but they should give them some old memories. So if we asked ourselves this question, is this acceptable? Right? Or, and let's put ourselves into this to say, well, we are now trying to find admission for our children into a particular school. And as soon as you walk into the school, this is what your, what the first sight that you ultimately see. So is that acceptable? And, or is this a better outcome? And that's a personal question that needs to ask, because it has ultimately led to the leadership as to what we are willing to accept for it, as we walk past and say, well, that's okay, or it is not okay. So the next, of course, is when you look at it from working conditions, and the same thing is, we will use the kids going to school, and and we say, well, what working conditions do our people prefer? And most of the time, okay, is that something that is acceptable with sand and dust, which is all the way around the, around the operations, right? Or is that something that is acceptable to us from, with things that are being lying around? Why is this important? Because these are things that ultimately says that what is our level of maturity and how we deliver safety, how safe we believe our people, need to be operating under. So, or is this what we are willing to accept? I accept that Foundry is a messy industry. Nobody's asking it for it to be spick and span, but it can be neat and tidy. And the extreme right is what was, the transformation from where it was on the left all the way through to the right, that says, okay, people started taking, ownership and leadership on what they were willing to accept within the operations. So the next thing, of course, is what were the work practices and process control that comes through. So so most important thing is with safety is what are the acceptable ergonomics that we are expecting our people to work under, and how the next, of course, is from a process control perspective. How do we ensure consistency of results? So I do not need to explain this, but the first top photograph is a core making thing that ultimately was being done, at the start of the, the transformation process. And if you look at it from an ergonomics perspective, a lady would bend down, pick up a bucket of sand, take it across to the, to the core mold, and then, and use it. So that is the thing to say, well, okay, if that is acceptable ergonomics, then we will, if not, we need to improve, make this thing better. So the same thing is, okay, that is, another contraption. When you really think about how does a person climb up, that contraption and pour whatever that they are doing into it. So yeah, so that's the, that's how it was, going, at the start of it. So the main thing, of course, is, with every operations, and I'm sure every owner or every plant manager or every organization, every business has got, there is some pride and reputation that you want to maintain. And the first question that comes up is, what is acceptable and presentable to our customers? And when I, again, take an example here, that if we are going to take our scooter, motorcycle, or a car to a mechanic for it to be repaired, and if that mechanic's place was like this, would you give your car to be serviced, and if you believe that you're going to get a quality product out of that workshop? Or is this something that you would be more acceptable and say, well, that is now a Foundry, and that is something that is unique, and therefore I would like to do business with this particular operation? Why important? Because as you begin to look at more and more international customers, and if you're looking for the export markets, with the first impressions and the quality of your the operations and those things become important, because that is one of the criteria that external customers use. I'm sure the same exists even for customers in India, but what I'm saying is, okay, that's why it becomes more important. So what is the core cause? And I suppose we need to talk about what the root cause is. Okay, it is basically the leadership and system maturity. So what tends to happen is, right, nobody is going to be perfect, right? And neither is everybody expected to be at their best levels, because it is based on the level of maturity and experience that each operations or each person has ultimately got. So different companies operate at different levels of that continuum. It is up to the transformation managers or the improvement people to then say, well, we will now raise ourselves from the basic level up to where, so that we become a much more resilient organization. And that was where the whole process ultimately started. So let's look at from a quality perspective. So what was the problem with quality? So we are only looking at from a reject rate perspective that says, well, what was the reject rate? And the reject rate in the past trailing 12 months percentage was 6.1%. And our benchmark for Foundries with those sort of products was around 1.3%. And the target we set ourselves to say is, well, it needs to be less than 3%. So what was the the outcome? Because the only thing I'm trying to highlight is, okay, this thing doesn't happen overnight, so it takes a long period of time for these changes to ultimately walk through and to begin to show up as numbers. And in between, you will begin to see there's a lot of variation. The blue line is the same reject rate, what the Foundry called as wasters. So yes, it was going up, going up and down based on as we identified various problems, but it went from from a high to the lowest of the delivered of 2.1%. So the cost of quality as a percentage was lower, but that was then the next challenge that was taken up. That's, well, how do we reduce the cost of quality, because we were losing some very high level, very expensive castings because of quality problems, and that became the next stage of going forward. Then the thing was with the main determinant we said was with with throughput volume, right? So when we started, we said, let's look at monthly tons. So the existing production out of that foundry was around 600 metric tons per month. Based on whatever the customer demand was and whatever the decisions had been made by management, we had to increase that by another 400 tons a month in the period of 12 months. So what finally ended up? We increased the target was 1,000 tons, and we were getting to we finally ended up with about 1,600 tons. So it is a continuous process. Again, nobody's saying that but there's a lot of effort that has gone into delivering that value. And what I do know is that till the maximum tonnage that they've been able to produce is currently, the last I've heard, is around 2,400, between 2,200 and 2,400 tons a month. So that's a huge difference from where it was about 600 metric tons. It is exactly the same piece of machinery and as it exists, within the operation. So that is the potential that exists by applying the right methodology. Same thing with the revenue, because through revenue growth requires increase in revenue. So the target that, based on what we said, is, okay, we need to increase our revenue by 167%. It ultimately increased by 300%. So what I was saying is, okay, yes, if you set yourself lofty goals and people are willing to contribute towards the improvement process, it can give you some amazing results. So next part was the velocity. The velocity as to why it is important, and the measure for that is your cost to dispatch days. Cost to dispatch days is basically measuring the time that I poured a particular casting, how much time is it spending stuck to the ground, within my foundry before it gets dispatched out to a customer. Because my belief is every casting that is basically dollar bills or rupee bills that are basically stuck to the ground. So the faster that you're able to get this process through the foundry, the better it is. So what did we finally get to? So this was, as a production increase, you could see that our cost to dispatch days began to increase. So it suddenly started to shoot up to about 105. And that is when we realized is, listen, there is a problem. We can't have castings because it was actually congested within that particular foundry. So we had to actually start reducing the overall cost to dispatch days. And therefore, we then started applying synchronous flow and those techniques to then start reducing. So we got it down to the lowest level of around 40 days. So that being the result as to, well, what was like we said, what was the problem? The problem was with queuing. Yes, they were pouring a lot more castings, but the castings were getting stuck in work centers, and there not enough castings actually being worked on. So in essence, queuing up of castings is only adding to cost. It is not adding to any throughput. So you begin to then look at what work centers and how to improve the throughput through those work centers. And that obviously you then apply different techniques to be able to apply for, to increase the throughput through those work centers. So the main thing is now trying to look at the overall set of operations to then say, well, what is the synchronous flow? Is how is the product ultimately moving through that whole foundry? Is it moving in a unitary direction? Are we moving the right quantity of material from one work center into the other? And whether or not that each of those that was being delivered was at the right quantity that the work center could ultimately process. So, and that ultimately led on to, the controlling of the cost to dispatch days. And I'll show you as to what happened with inventory slightly soon. So what happened from a customer delivery perspective? Now, the customer delivery, again, is important. We know it was, the DIFOD was running at around 45%, which is not a very good number. So our benchmark we set ourselves was to get to, how close can we get to 100%? But we said in the 12 months, see if we can get to greater than around 85%. So what was the result that came out of the DIFOD percentage? So we were all beginning to, well, how many orders do we have in backlog? Okay, so this is what the the maximum that we were able to drive towards the improvement in DIFOD was only 70%, which is still not, we did not meet that particular target. And yes, there were various reasons. We knew what those reasons were, but the difference was that the 15% was getting missed by less than 3 days. So it was more a problem with, not with the production of the casting, but the administrative processes of actually getting these on a truck, in time to be able to then raise a delivery docket and then get the product shipped to the port. And therefore, I suppose that was the next thing that had to be worked on to improve the DIFOD percentage as to when the castings left the foundry. So one more thing is, of course, the yields and, from the method yield. So, yes, the root cause was ultimately old thinking and old software that existed within the software. Just hold on, sorry. Okay, so the old thinking and the sorry. Yeah, the old thinking and old software. So what it ultimately meant was, yeah, that is how the castings look like. I'm not a technical metallurgical person, but that does apply to be elephant that has got too many too fat legs. So and it was left. We were currently existing at around 67%. The benchmark was 75. The 12-month target was to get to 73%. So so those were the type of casting that that went along and existed. And how was this ultimately solved? The main thing is to giving the technical team the right tools, and then the team was challenged that says, well, let us see what you can do to deliver this improvement in the yield. And this is what ultimately happened. That says our target was to get to 73%, and we got to 73%. So what I'm trying to again highlight is, yes, the tools are important, but it is the motivation and the drive of the individual people to deliver that result ultimately matters. Next, of course, from a cost perspective. So the main problem that I want to highlight here is with our labor costs. The labor costs, the existing labor hours per ton was running at around 45. The benchmark was around 21. So the target was around 30. And the main root cause, of course, was with crew size and the rework that was causing those problems. So if you see that there are, a few of the things from an operations perspective, we just had, too many people because they did not have much things to do because things were not flowing through correctly. And therefore, we had multiple people, waste of resources. On the right is, of course, is all the rework that was coming through because of, the problems with our cores. So, and a lot of rework was then required to then get the castings into a stage to be able to process, into a finished product. So what then the solution and the thing that was applied was demand supply balancing across each of the work centers, and the quality project as to, well, how to reduce rework. And if we looked at as to, well, yes, it was delivered. Our target was to get to 30, but with the lowest that we got to was around 32 hours per ton. So yeah, so in each of these areas, you could see that the techniques or the tools and tips that we applied actually started to deliver results. So the reason I say from an economies of scale and labor utilization as to why it is important is that if we looked at the numbers, we increased production by 266%. So the question that is, well, how much should labor numbers have increased by? But in most cases, the general thinking immediately you would say is, oh, if you need more production, we need to increase our labor. Our labor increased by 15%. It was around 238 people at, direct operators working in it. That increased to 275. So a 15% increase in labor numbers delivered a 266% increase in production. So what that ultimately says is, okay, there is always dormant capacity within your existing labor force. It is now trying to extract that by applying and first of all motivating them and then applying the right techniques to get, to improve that labor utilization. Next thing, of course, is from an energy cost perspective. So electricity cost reduction. So if you look at as to what the tools that were done with, from a methods yield as well as from melting. So what happened? This was the electricity, the electricity consumption trend. So it went down from $1.72 to not $1.72, whatever, $1.172 units to 1.11 per kg. So which means says, okay, yes, there was a more than 30% reduction. The next, of course, is from a LPG cost reduction. So the tools that were applied again is with yield and utilization within this time around the heat treatment furnaces as to, well, how do we now improve the yield and utilization of it? And what came out of the LPG out of there again was a decrease from a high of around 63 down to 44 again, and greater than 30% improvement in energy use, and therefore also therefore a significant reduction in cost. So then again, from an inventory perspective, we had a very high inventory primarily because of uncoordinated decisions, right? So, our existing was around 63 days worth of inventory, of days of inventory in stock. And, we had to reduce that thing down to 55 in 12 months. And by applying the same various techniques, this is, so the blue line is the finished goods, the red line is the work in progress, and the green line is the raw material. So that is what was ultimately reduced while still increasing the production from 600 tons down up to 1,600 tons. So yes, yes, it is possible to, so this has a direct effect on working capital and cash because you're still producing high levels of production at a very optimized inventory level. So you tell me as to, well, what were the results out of all this, Girish? So you show me the money. So so this is what was the money part of it. So the various initiatives as we measured them, as we went through. So yield, quality, labor, material, variable cost, and manufacturing overheads each contributed towards the profitability. So what was the size of the price at the end? So within 12 months, the safety performance basically got to 0 LTIs. So we did, in 12 months, our throughput increased from 10,000 metric tons per year down up to 20,000. The cost was approximately reduced by 20%. And what was the profit improvement that delivered a 5 million gross profit improvement to the operations. So 5 million is not a small number. So that we had to highlight is, yes, if you put in the effort, there are some big gains that are, that can be made. Now let's take another example. And this is example as to how to reduce the cycle time reduction and, what were the results that you can get by improving the cycle time. So this is again, yes, we did a lot of other projects within the Chinese foundry, but the main thing what I will highlight is the foundry and what we did with cycle time reduction. So this is the foundry again in northeast of China. The problem with the foundry was that the foundry capacity was considered to be full, and the lead times were blowing out, and the customer lead times got up to about 6 months for a product that was coming out of that particular foundry. 6 months was unacceptable to the customers, so we had to work on. So they said, Girish, have a look at this and see what we can do to improve the lead time. And to improve that lead time, we had to actually increase the throughput, but I will explain how. And so what the initiative that we went along and picked up is to work on the tap-to-tap time improvement. So the total initiative was that we had to improve the melt furnace productivity, to increase the dress tons per day, so that we could, that was through reduction in the tap to tap time, increase the furnace yield at the same time, and reduce energy consumption as we go, as we increase that throughput. So yes, there was an improvement team put together. So yeah, so the right improvement team, usually, with the line managers that existed. So, everybody worked hard to be able to deliver this. So the first thing, of course, is, from an initial state, that the what was the, we had to measure what was the existing state to say, well, what is the tap to tap time by product? So we went along and measured, yes, there are different products that are going through, through that particular foundry, right? But we picked on, yes, there are different materials. Yes, you have special materials, and it takes longer for the tap time for those, because of it's not easy to change the chemical composition. Don't ask me how, I'm not a metallurgist. But so what we ultimately did was, okay, let's pick one material. Okay, I've hidden the material name so that there is no confidential information provided. So we picked one material as the pilot. We said, let's apply the 80-20 rule, and we will solve for the majority. So what we started was, okay, that particular material was greater than 70% of the product mix. So it said, let us now start with, solving the problem of the tap time for that individual material. So we had to then stay to say, well, can we break up that cycle time? And what is the breakup? So the breakup ultimately said is, okay, those are the various things. So the top thing, of course, is the total tap to tap time, which is made up of what we called as a power on to tap time. This is the actual melting time. And then we called it the tap to power on time, which is basically your charging time. So the combination of those two ultimately delivers what is the total tap to tap time within that particular furnace. So what we worked out for this particular material, the tap to tap average over the multiple months was that it was running at 88 minutes. The power on to tap was around 72 minutes for the furnace, and in most cases, the tap to power on, or the charging time, was around 16 minutes. So that gave us a benchmark that says, okay, well, that is what is the breakup of the overall cycle time, and we could then address each of those separately, and that's what I will show you now. So we first set ourselves to say, well, what is the tap-to-tap improvement target? So the improvement target for, when we looked at for this particular material, we said, okay, at current charge speed is we're taking a 16 minutes as an average for every heat. Can we reduce that as a target down to 10 minutes? So we reduce by 6 minutes per heat. The next thing, of course, is that we looked at from a Pareto perspective that says, okay, well, what are the reasons for delays within the power on to tap? Why is there delays within? So there were issues that says that the top 5 or 6 delays was causing 70% of the delays. And for people who can understand, the ones on the right were the top reasons why the causes of the delays within that particular furnace for that thing. But if you look at the bottom, those are all common things. That doesn't matter what is the type of material that you're actually casting. Those are common things that across that. It does not matter what the type of material is, the delays are common right across the board. So the root cause analysis was next done to say for each of those, to say, well, what are the causes for the reasons with back charging? What are the causes for what is happening with the AOD? And that then led on to the improvement action. So that highlighted that said, well, what are the areas we need to stop doing, what we need to do less of, or what do we need to do more of? So that being the case, that led on to the incremental result that says, okay, as we started working on addressing each one of these, so that basically said is, okay, but every activity was ultimately completed. That is what was done, and over a period of 12 months, the incremental small results, that was able to be sustained over a longer period of time. So what was the improvement results? So the improvement results was our tap to tap, so the tap to power on time was reduced down to 10 minutes in 12 months. So what did that mean from a results perspective, from an individual process, as well as from a foundry perspective? The improvement results by reducing the tap to tap time with the number of heats increased from 13 a day to 16 a day. So there's an extra 15 dress tons every single day in increase in production. So that 15 dress tons equated about $20 million in excess revenue, at $20 million at the right margin was around like $6 million in gross profit. And in addition to all of this, that we now had an energy cost saving of around $400,000 a year. So there again, see, there are incremental changes, but at the end of the year, you can get some really big numbers. So, well, that is the end from the story of the two foundries. Well, we would then ask is, well, how did the story end? Thanks, Girish, for the story, but what happened? So both the foundries ended up getting global recognition. So one foundry got the best foundry of the year. The other one got the Global President's Award, and they were applauded for what was achieved across across the operations and what they were able to deliver. So so in essence, yes, there is the prize at the end of it, and I'm sure each of the foundry people were really proud of what they've gone along and achieved. So this is hopefully the last part, and I won't keep you here for much longer. So, well, what are the next steps? And therefore, that is more important for you. So we know that it is possible, but what is required is what is the best practice. So in essence, you do require that improvement roadmap, and you've gone through each of those steps within that roadmap that ultimately says is, okay, this is the way that we need to do our improvement projects. And yes, it needs to be sustainable, and and that is something that can be applied and that will deliver results. The most important thing, of course, is the iterative methodology, because this process does not stop with just doing one project at the end. But generally, that is what tends to happen is companies stop it by doing one project rather than iteratively applying this over multiple things. But basically the methodology is primarily the same. So you're looking at your CPOCs, right? You're doing a risk assessment, what to target. You're then identifying what is your, the issues that you have. You do the root cause analysis, and then you execute. But what usually delivers results is purely on the execution. You don't execute very well, you don't get the result. Doesn't matter how much effort you put in, execution is the only one that ultimately delivers you results. So the final question gets down to is, well, when do you need to start? So, well, my recommendation is everybody needs to execute now. So anything that you have learned, if you can apply to your workplace, please go ahead and do that from tomorrow. The reason is the longer that you're taking to take action, the more money that you're ultimately losing. Because that is, the whole idea of the presentation, and the reason for the existence of your operations is that you want to be optimizing how much money that you're making out of your operations. So I do wish you all the best with the implementation of it. So just to the end this whole presentation, I suppose, thank you very much for the opportunity. If there are any questions, I'll take them now. But if you need any more information, there's enough contact details available. I'm more than willing to help you out, answer any questions in specifically for what is happening within your operation. So thank you very much, and over to questions.
Thank you so much, Mr. Hebbani. Now we will request the delegates. If you have any question, you are free to ask, please.
Shall I ask?
Yeah, please.
What is the exact meaning of the world class? Are there any standards for that? Are there any standards for that?
Okay. There is no standard for world class, and there again is what we believe that we want to be, and that comes from the benchmark that we set ourselves.
So
it's a relative term. Yes, agree.
My world class is different from your world class.
Agree. Yes. Therefore, it's a generic term. I accept. Yes.
So, Mr. Hebbani, my question is, because I got joined late, so I missed a lot. Whatever you described, as I could find out. Joining late, the process, changing the process and changing the methodologies of the existing, equipment or whatever it is there, can't be increased by improving the technology, rather bringing in new equipment and all that? which can give you a much bigger jump in the entire increasing the profitability and also improving upon the systems.
Yes, definitely. Right. So, as an example here, that yes, the core making went from a manual process into an automated process, and that therefore delivered better quality cores, and it supported the throughput. So I totally accept. But what tends to generally happen with a lot of operations is that we tend to apply automation into processes that are not capacity constrained, or is not going to contribute towards your overall throughput that will deliver your revenue and your profitability. Right. So, okay. So I'm all supporting of applying the right technology to the right work center or the right process, so that you're now getting flow through the process, so that you're now providing the right amount of demand to the next stage process, so that it can be processed. So I accept that technology has a role to play, but we don't start with that says, let's apply technology and bring automation into this, because the problems are more addressing the people and the utilization and those things first. Because if not, you will just get, because if the current operations are in chaos or very inefficient, you'll then get an automated inefficient process in the future.
Okay, thank you.
Sir, I'm Saravanan from Indoshell Cast.
Yes, sir.
Sir, in your presentation is very informative, very nice presentation. In your presentation, the catch is increase the production from 600 tons to 1,600 tons with the same existing machinery.
Correct.
Conventionally, what we are doing is to improve the productivity or production. We will try to improve the yield or reducing the rejection or improving the efficiency of the machinery, something like that. But even though we will achieve 15 to 20% by implementing all those things, but achieving 600 to 1,600 ton is really a remarkable achievement. If you throw some light on how they achieved these things, so it will be very useful to the foundryman.
Okay. So the most important thing that we already identified was that your melting is your golden goose that provides you the best results. Correct. So the focus with every foundry needs to be, how do I increase the melting? Right. Because the more I'm able to melt and more I'm able to cast, the better the throughput through my plant will be. So that being the case, so both in the China case as well as in the South India or the Indian case, right? I've only highlighted some aspects of it, but in most of the cases, even in the Indian foundry, they worked on the cycle time of the foundry. So there were two things that were worked on, as to, well, how to improve the tap to tap time within that foundry, that increased the number of heats that they could do per day. And the second thing was as to, well, how to improve the yield of the foundry. Yield of the furnace, right? So the yield of the furnace was basically being determined by that says, well, how much are we casting, how much are we charging into the furnace, and how much are we pouring into saleable castings? So when we looked at that number, most of it was either being lost because of pig. Pig was running at around 8%, and then your heel, and I don't know the technical term here, the heel that was left within the furnace was running around 6%. So if you look at it, whatever we were going through this whole process, but not pouring all that metal into casting. So that was the other area that was worked on that helped improve the not only the number of heats, but in every heat the amount of metal poured into castings actually went along and increased. So that is those are two major things that delivered the improvement, that why they're able to do 2,200 tons now.
Can I?
Yes, please.
Yeah. Mr. Ivani, as a customer, most of the time when we go to the supplier and we discuss a lot of improvements, but what I found was the priority from the management changes next day to attend some other customers. Now, maybe you may have this experience. Can you put some light on that and stress?
Okay. So if we looked at fundamentally whether we deal with our suppliers or customers deal with us, the criteria that the customer is evaluating on are only few things. Okay, well, okay, are we getting it at the right price? Right? Okay. Are we getting it at the right quality? Are we getting it at the right, lead time? Right? Okay. And so does not matter what it is, because each of those is somehow affecting their operations and not getting them to make their money. And therefore, they're now trying to get their suppliers. And we tell our suppliers that says, well, if your material doesn't come in time, I will have 20 people sitting idle. Therefore, you now need to improve your delivery so that I do not lose money in my operation. So if you look at the base things with every customer, there are only those 4 or 5 things that customers will look at. Yes, you can jump from one supplier on to another, but I know every customer, ultimately the CEO or the owner is looking at it on a monthly basis or on a yearly basis, how much money is showing up on my bottom line. Right? That is the reason for existence of the thing. And therefore the presentation says, well, how to improve profitability, because unless we are delivering that, anything else that we're doing is not of any value.
No, I just want to rephrase my
Sure.
question. I was talking about the supplier management. And we
Okay.
go to suppliers,
Yes.
Foundry,
Yeah.
and then we discuss a lot of things on quality, delivery, everything.
Yeah.
And then we agree certain things.
Yeah.
And later, the priority changes for them. And again, they go back, to the earlier status.
Okay.
So how the management should address this?
Okay, so
Foundry.
all right. So I'm sorry, I got the question slightly wrong. Okay, so the way we have ultimately addressed is that you then work through whether or not how important are you as a customer to that particular supplier. Right? If you're a 1% customer, yes, they will go back to what they are been doing. So you need to start from a position of authority that says, okay, if I am a 20% customer, I have some level of authority to then be able to dictate to say, well, that is what is the thing, because if not, you will lose 20% of your revenue as to what we do. So that being the first one. Okay. The second part where it tends to fall apart is, okay, the people who are ultimately talking to suppliers and the people who are doing the day-to-day transactions with the suppliers are 2 different people. Right? So the way we have addressed is, okay, we now have a monthly, apply the same metrics to the suppliers, and we call them in for every month on things that we will now review your metrics for how you're delivering and your quality, your delivery, your cost, and and those things. So yeah, so once you then bring that, then know that somebody is willing to ask a question the next time that we have to either give them a reason or we will lose that business, people very quickly go out and change. It's worked for me, but I suppose I do not know enough for your unique supplier customer relationship.
No, it was not unique to the supplier. Probably it was to the most of the suppliers.
Okay.
Of course, the message has gone to the Foundry top management now. I hope so.
Yeah, agree. Yes. Because no company can grow by losing customers.
Yes.
Right? So the top management, that's what they're looking for. So, and that's where it becomes important.
Your email ID, please, Girish Hebani.
Yeah, girish.hebani@outlook.com. If you need to reach me personally, yes.
Girish.hebani.
Yeah.
At
outlook.com.
Outlook. Thank you.
Now,
Madam, any questions in chat box?
there was a question by Mr. Govind. Mr. Govind is there? He spoke about that the South Indian foundry example showed huge variation month on month and not a progressive improvement. So he said that is my concern with respect to sustainability of progress achieved.
Okay. See, because there is no magic wand that anybody can bring and say is by tomorrow morning, all your processes will be fixed. Right? So you start from one area and you can't fix everything together. So you start from one area, you will end up with trying to improve something. Then you find there are other problems that, that the increase ultimately brings about. And unless you solve those problems, it is never going to be a straight line. A straight line only exists in Excel, where you put a percentage increase and you drag it across, it will come across. But in most cases, that is the reality, because those are actual numbers that actually there, within that particular foundry. And looking at those metrics and reacting to those ultimately delivers the improvement. Right? And not 100%, everything that you do does not end up, you end up failing, doing something. So it is never an easy thing that it will continuously keep improving, but we need to allow people to fail. And therefore that is the much better learning, so that we don't do the same mistake again the next time.
Okay. Thank you. Thank you for all your presentation and clarifications.
I think
Yes.
what is the percentage of energy cost? That's what
I said I would not want to share percentages, because these are real companies that ultimately exist, and the idea is to show that this is what is ultimately there. But I suppose the if you need a thing, send me a thing. I'll give you an approximation as to what the energy cost was of the total operation. Because I'm just being careful. I'm not giving out any confidential information or commercial in confidence information to in the public forum. So yeah.
Yes. Yeah. Myself, Chandrasekhar, Girish, very nice presentation covering all the 4 M's: man, material, machine, and method. You started off with the safety.
Yeah.
Safety is, I also feel it's the most important, and you have touched upon that. I really, that's one area normally we, many of the foundries, we don't focus on that. But because we are with a few Japanese foundries, the moment they come for audit, they look for that safety
Exactly.
aspects.
Yeah.
So, and the safety comes, and then the housekeeping, all these things definitely. And you also presented with a lot of details, analytics you have done. It's a way of, I think, rather than doing some chumantra to get the results, you have showed the way how to make profitability through 5 years. And what was the time frame you, with the South Indian and Chinese company, you achieved your results? What was the time frame?
Okay, see, it is a continuous process. So what I've presented is what we delivered in the first 12 months. Right. So so then so as the foundry, that's what I said. Okay, the South Indian foundry currently delivers about 2,200 tons a month, with a lot better, greater than 85% delivery, less, very good quality. So same thing is with the Chinese foundry. So the Chinese foundry.
Yeah, sorry. You also said one tool does not solve all problems. So
Correct.
how do you select those tools? Depending upon the intensity of the problem, or how do you select those tools?
Yes. So in most cases, as part of the evaluation, you end up with, well, what are my most pressing problems? Right? So rather than looking at it from a tool perspective as to how do I use a tool to solve a problem, right? We say is, okay, this is our most pressing problem. Our major problem from our customer is, say, delivery, right? Or our quality. Then you say, well, okay, let's look at the quality problem, understand what the causes are and what the root causes are and how to solve that problem. Because if not, you will say that, okay, because I've got a quality problem, you will say, I will apply TPM principles. So you then go through, applying TPM. Right. Yes, it will solve quality in a correct. But whether or not it is solving the problem from a customer perspective, whether it is going to deliver you increased throughput or more customers or those things, it loses out, because everybody is concentrating on, because in Australia, we say is, okay, if you've got a hammer, you'll only look for nails to bang and do, right? But if there's a screw, you do not know how to, because you've now got a hammer, you do not know how to fix the screw. Correct? So you need a hammer as well as a screw, as well as a pliers, as well as everything else to fix all the various fasteners, because you've got to be fixing a fastening problem.
Yes.
Yes. So therefore, yeah. Okay. So
recently one of our customer was asking how China is competitive than India. I was telling about the lean organization structure. like China doesn't have too many what you call white collar people. So how do you look at that, Girish?
Okay. So it is not that the org structures are very different to what it is here in India. Right? Okay. So some of those things is, yeah, because they are comparing very large operations compared to the operation that exists within India. Now, my thing is China, because of whatever that they are doing, they're a little bit more efficient because they've got a discipline. They've applied certain techniques already within their operation that is delivering them better quality or better products, at least for the international market. India, again, is only, like I showed the maturity curve, is that, okay, China maybe is 1 step or 2 steps ahead than where India is. But India can apply the same things to then get to, I'm sorry to use the word thing world class, but yeah, you're always catching up to whoever is ahead of you to become as good as, you know, what they are. So that is where the difference is. And in most cases, our problem is everything that I've highlighted. We've got the labor, we've got the technical expertise, we've got the machines, but it is the inefficiency that is ultimately driving your cost per kilo up. And because you're then doing cost per kilo pricing, your price becomes too high from a customer perspective. Right? Because it's an example with the South Indian foundry. Yeah. So the cost reduced by 20%. That 20% reduction in cost then brought in a lot more customers who were now willing to now buy at the right price point. And therefore, then if you look at the reason why we got to 1,600 tons and even further was the price point that we were able to match from a customer perspective, what they were willing to pay. So you then get into an outward spiral, as we call. It's okay, your cost reduces, therefore your pricing gets better, you increase your customers, your cost reduces further, and therefore you now get into, you know, improved revenue and profitability.
I have a question, sir. Dev Dulgar.
Yes, go ahead.
Okay, so I belong to Kanpur, and this city is in North India, Uttar Pradesh. And seeing your presentation, it was very nice. And basically, I could have an idea. It was more practical for large and medium foundries. But if we talk about MSME foundries all over India, they're contributing much larger. They're contributing a very great proportion to the manufacturing sector. Especially this city is comprising of 95% of micro and small foundries. Do we have any kind of strategy we can do it for here?
Okay.
In Kanpur?
And that's what I wanted to highlight. I've only taken examples of larger foundries because that is what I've got examples for, right? But if you look at, doesn't matter whether it's a large foundry or a very small foundry, it is still going through the same thing where you're converting a raw material. The quantities might vary, right? Your size of your furnace and the tons may vary, but you're converting your raw material into a finished product for a customer. The size may be 0.5 kilo, 1 kilo with an investment costing, right? Or, you know, or it could be 35 kilos or 40 kilos. But if you look at the process, it is what we are talking about is improving the process. You get large results when you're now talking about 15 tons more because you've increased, you know, the number of heats. But the same process still goes through the same thing because you still go through melting, you go through molding, you go through coating, you go through melting, right? Yes, there is cooling off. Yes, there is fettling, heat treatment, or whatever your processes are, surface treatment. Those things are common. So you can apply the same concept to, doesn't matter what the size of the foundry is.
Okay. But
right?
the
So
cost element, of it, the implementation part and the monitoring part is a major factor that might lead to the success or failure of this.
Correct. Okay. And that's what I'm saying is that, okay, I've done manufacturing companies, right? Which something, okay, which is, you know, I'm currently consulting with a company that produces about 60 crores in a year, right? So 60 crores in a year, I cannot then say, well, you need to bring in all these various systems. You then now adjust that, say the same thing is, okay, they've got a coating machine that is, you know, that is capacity constrained. You can now apply, you know, with very basic things to how to improve the throughput through that particular machine. So it is not size specific. It depends on how much you want to do and how much you want to take on at any given moment of time. So if you got one person, if you got two people, you can still apply and do one process at a particular time rather than doing everything.
Thank you.
So, and again, you can talk to me. I can give you specific examples specifically for your operation, but yes, it can be done. So it is size agnostic. And therefore, that again, for the first comment I made was, yeah, the movies may be different, the stories may be different, and the actors may be different, but the method of making a movie is exactly the same.
Exactly. Yeah. Totally agree.
Yeah.
Thank you.
Girish, how was the commitment from the top leadership about these activities to be taken?
Okay. And that is is the first hurdle that I would ultimately take up. Correct? Because if you can think, okay, the reason is, yes, we do have people who've been there in these foundries for 15 or 20 years, who are trained metallurgists and been doing this day in, day out for a long period of time. Correct? So I have to come along and tell them that whatever that they're doing currently is actually wrong. Not being a metallurgist, right? So it becomes more of a pride and an ego problem. If I use a Hindi term or a Tamil term, right? Okay, so और अरे तुमको ये कैसे मालूम है, हम लोग 20 साल से यही कर रहे हैं, तुम आके हमको नया क्या सिखाओगे? तुम जो बोलोगे वो यहाँ पे काम नहीं करेगा सर, वो ऑस्ट्रेलिया में काम करेगा, यहाँ नहीं करेगा. So that is the mental block that you have to get over. And yes, there are different things, like you said, is working with the leadership, and therefore the AGNA Academy part of it, because I need to work on the people at the same time so that they can ultimately take ownership and deliver results. Because if not, they would say
okay,
yeah, let's see how you will go out and do this. And I've had that problem. We will make sure that you will not be able to deliver this improvement. So if I get that resistance, then the whole thing falls apart.
Good. Nice. You had a very good,
thanks for this message, because this is what I was expecting.
Mr. Girish, Mr. Girish,
everywhere. Correct.
Yes, sir. Go ahead. Somebody is asking.
Mr. Girish, you said everything which is compared to Europe and Chinese. We are very much behind. That is understood. We need to take so many techniques with us to overcome the whichever improvements you have said. But there you might be understanding the Indian situations are very much different than these countries. But still, our people are very much ready to work for even 7 days, a week, isn't it? But it is not the situation at Europe. You might be knowing they wanted to work only for 5 days, but here our people are ready to work for 7 days also. Because with this only we could able to achieve the results whichever are targeted. That is happening from several years till date. But you might be understanding that why we are losing in between these weeks, because there are so many external influences, external conditions which are influencing our system of working. See here, instability with the interference of political also, and the conditions outside. So because we have not that much good infrastructure in India, but now it is building, and over in coming periods it will be definitely improved. But at this moment we have a big challenges to fight with these conditions also. In spite of this, our people are ready to work for 7 days, but we don't have a culture of 5 days working and achieving the same targets which we are achieving with the 7 days working practices. That is the situation. This was very difficult in past days, but now it is improving because the tool handling system which Europe is having is much ahead of India. They are much ahead of. They are in fact I will say they are ahead of 100 years than India. These are the situation. In spite of all these things, still we are achieving. Do you think that we are doing much better even though fighting with these situations?
Okay. And I appreciate everything that the Indian industry is doing based on all the constraints that exist, like you mentioned, external, internal, everything that is happening. But what I want to share is an insight of having worked in 15 countries. People in every country are exactly the same. It does not mean that if they've got better technology, better tools, that somehow their productivity is better. So I have done exactly the same thing in foundries in Canada. I've done the same thing in foundries in Australia. I've done the same thing in Malaysia. So, and the US. So in essence, it does not mean that, okay, the things are any different. Yes, there are a number of extra constraints and conditions that exist within India, and people deal with it. But what is the common thing across all people right across the world? Right? Okay. Ultimately, they need to be motivated to put in the effort, right? Okay, they need to be shown what is the right way of doing things, right? The second part of that comes through is they need to be recognized. And the final thing is they need to be rewarded for their effort. And that is common in every country, anywhere around the world. And the same thing was applied at the South Indian thing, because the first thing is recognizing that their existing operations is not because of anything wrong with the people, but it is ultimately getting them, to help improve the process. And that is where it ultimately starts. So I accept that, I guess it is that much more difficult, but you will still find is that you've got an added advantage of actually getting ahead, because with 7 days of production, you will be much further ahead compared to any other organization outside of India.
Yeah, understood. I got it.
Thank you.
Hello. Hello.
Yeah, go ahead.
Sir, you mentioned that one must give the attention to uptime rather than downtime. What
Correct.
is the concept behind that?
Okay. Let me take a simple example outside from a foundry perspective. Everybody follows Formula One cars, right?
Yeah.
Race cars, right? Okay. So a Formula One car exists, whether I drive it, the machine is the same, or Max Verstappen goes along and drives it, or a race car driver drives it.
Yeah.
Right? So what I can get out of that same machine during its uptime is different to a way a seasoned race car driver like Max Verstappen can get out of exactly the same car. So what is the difference? And therefore, the concept, okay, how we utilize that particular machine during its uptime is what, right? Because if the machine can run at 400 meters per hour or whatever as an example, and we're only running it for 200 meters per hour because it is stopping and starting, then we are, even though the machine is up and running, you're not getting the required output or throughput out of that machine. So your uptime performance is actually lower than what it should actually be. Rather than we tend to think about, oh, the machine is down and therefore we need to fix maintenance practices that happens 20% of the time, rather than looking at what is happening 80% of the time.
Okay. And next question in relation to this, that how do we compare the performance of the uptime within the foundry itself? So the machine is same, okay, and other foundry and this foundry, the same machine is giving the result, but we generally we don't have the information of other foundries of the same machine. So how do we compare the results inside the foundry itself, that this uptime the machine is giving the result, and is it correct or is it required to be improved?
Okay, so there are two ways to look at it, right? One is you do not need to compare what other foundries are doing, because it is not an apple to apple comparison now. So the first thing that we would do is, okay, what is the rated capacity of that piece of equipment?
Okay.
Right? Because, okay, your supplier of that equipment should tell you how much is your rated capacity that, okay, that furnace is supposed to melt in 60 minutes or, so many tons in 60 minutes or kilos per so many times, right? Okay, so you know what the rated capacity is, and then you can compare what is that furnace delivering in actual.
Okay.
Okay,
Yeah.
so that is the first thing. So in most cases, what then happens is you're then beginning to say, well, what is the downtime? Am I not getting enough production because of my downtime? But like we said, you then concentrate on what is happening in the uptime. Correct? Okay. So you then start breaking your uptime down, that your uptime, the machine is not working 80%, 100% of the time, is because I've now got stoppages.
Yeah.
Right? Stoppages because I'm now changing, from a foundry perspective, okay, I've now got a change in specification between from from one material onto the other. The molds are not ready, right? Okay, now I've got a problem. It is taking too long, right?
Changeover and all
changeover
other things,
setup and whatever those things are. So you then start concentrating. That is, how do I now reduce the stoppages so that I get more uptime and therefore I get more production.
Yeah. Right. Thank you.
So it was a very interesting session. In fact, we planned this session in such a short span of time, and there was a lot of interest. We have seen our past president like Mr. Subodh Panchal and Ms. Prabha Kulkarni. They also attended this session. So thanks a lot for this session. So now may I request our Honorary Secretary, Mr. S. Muthukumar, to deliver the vote of thanks.
One last question can I ask? See, the people everywhere are similar and having the same habits everywhere. See, working in different countries. Do you suggest that we should have such techniques in tool handling that we should overcome the habits and failures due to manpower? Would you like to suggest any tools with respect to that?
See, technology and IoT is a possible solution, right? So each of these processes, yes, there is advanced technology that is available. What I cannot comment is what is from a technical perspective, well, what is relevant to your particular set of operations, right? So so that's that difficulty. Yes, in most cases you can bring in technology. You got the ability to actually leapfrog or actually get ahead of what others are using, because you can then do capex that to support your growth. You're now getting the much more modern technology into your operations that can deliver better results. What it is, I cannot tell you, but what I can say is, okay, that is the opportunity that exists. But if you want to get ahead of the other people in any of the other countries, you bring in the latest and the best technology that is currently available and put it into your operations.
Yeah. Muthukumar, you can proceed with the
Yeah, yes, sir. Good evening to everyone. On behalf of Institute of Indian Foundrymen, I would like to extend my heartfelt thanks to all the attendees who joined us for the insightful webinar on 5 levers to pull to improve profitability in foundry operations. First and foremost, I would like to thank our ED madam who taken this responsibility within few days and arranged this webinar and made it very successful. I thank you, ma'am. Special thanks to our president, sir, for the welcome address and always inspiring us to make the webinar on time to time on relevant subject to all the foundrymen. Thank you, sir. A special thanks and big thanks to Mr. Girish. I have spoken with him only 1 week before, and he want to become a member. And from there,
very good.
From there the journey started. Within a week's time, we made a webinar, and we are going to conduct one more program at Coimbatore also. And today he has taken us throughout the world with all these experience and everything. Thank you, sir, for your wonderful topics. and hope the members have got the benefit out of it. And I thank all the participants for actively involved in the session and asking more questions. Thank you all. And once again, I thank all the staffs who are behind this program to be a grand success. Thank you all. Thank you so much, sir.
Thank you very much. Yeah, hopefully, thanks. Yeah, thank you for making it.
Thank you.
Thank you, Mr. Ibani. I would
Thank you,
also
sir.
request you. I would also request you to contribute your article in our journal.
Sure.
Foundry
Yeah.
journal.
Yeah, I can do that. Yeah.
Thank you.
Sure. Thank you.
Okay.
Thank you. Thank you.
Thank you.
Okay.
Thank you.
So thank you very much. Bye, everyone.
Thank you all. Yeah.
Bye.
Babu, thank